Hey everyone, today we're doing 9.3 properties of rectangles, rhombuses, and squares. So first off, what is a rectangle? Rectangles are parallelograms with 90-degree corners, but as it turns out, there's actually a cool property with these guys, and it has to do with their diagonals. As it turns out, the diagonals are congruent. So we can actually use this property to draw some conclusions for things. For example, we could do number 5 here. It says that AD is 7.5, so AD is 7.5, so we can mark that, 7.5. DC is 10, so DC is 10. It asks us to find DB. So DB is this one here, but we know that DB is equal to AC, right? Could we calculate what AC is? I hope so. It's a right triangle, so we could calculate DC or AC, sorry, by doing 7.5 squared plus 10 squared, right? A squared plus B squared equals C squared, or we could square root that to get AC, which is equal to DB. Okay. Astute readers will notice that this is actually a 3, 4, 5 triangle. This is 3 times 2.5. This is 4 times 2.5. So this is 5 times 2.5. So 5 times 2.5 is what? 12.5. So that's the length from A to C. Or you can work this out on your calculator. Feel free. Okay, we're going to do the next one. It says AB is 17. Right, a new problem. So AB is 17. BC is 12.75. 12.75. We need to find DB. So again, DB here is equal to AC. So we can say that the square root of 17 squared, A squared plus B squared, 12.75 equals AC, which is equal to DB. Again, this one actually turns out to be a 3, 4, 5 triangle. 17 divided by 4 is 4.25, which is this thing times 3 is this thing, right? So this is the 3, this is the 4, this is the 5. 5 times 4 is 20 plus 1.25 should give us 21.25. You can check my math on that with the calculator. Okay. We have some other ones called rhombuses, and hopefully you know what a rhombus is, but essentially a rhombus is a parallelogram where all the sides are congruent, right? So there's some properties of rhombuses, and the properties of a rhombus are that A, it's a parallelogram, the diagonals, in this case, I can draw them. So what's true about these diagonals? They're actually perpendicular. I didn't draw that very well, but they're actually perpendicular. That's a 90-degree angle. And then finally, one other one. What is this? It's a little more clear here. The angles, when you draw the diagonals, the angles are actually bisected. So by drawing that diagonal, I bisect this angle here. So opposite angles get bisected. Okay. So we can, again, use this to solve problems, and they throw some algebra in here at us, but we can handle it. For example, we need to find what xy is. So x to y. So we need to find this length here. It tells us that it's a rhombus, so we have all of the properties of a parallelogram and all of the properties of a rhombus combined in this guy, so we know that xy is equal to vw, which is equal to xw. Right? All of these sides are congruent to each other. So we can figure out what 6m minus 12 is equal to 4m plus 4. So we can say 6m minus 12 equals 4m plus 4. We solve for m, and then we plug it back in, and we get our length of vw, or the length of xw. Doesn't matter, they're both the same, which is 36. Therefore, xy is also 36. Okay, we'll try another one. This time we'll do it ourselves. We need to calculate what angle YVW is. So Y to V to W, we want to get this whole angle here. This number refers to just angle WVZ, so just half of it. Diagonals of a rhombus are what? They are perpendicular. Perpendicular mark. So I'm going to draw this little angle here. Boop, boop. That's 90 degrees. That's 90 degrees. So WZX is a right angle. So WZX is a right angle, and therefore the measure of angle WZX is 90. So therefore we can set 3n squared minus 0.75 equal to 90. And we solve for n. Add 0.75 to both sides, and then divide by 3 gives us 30.25. Okay, and then we need to substitute that value of n in to find the measure of angle WVZ. So we can plug in n times 9 plus 4. N times 9 plus 4 gives us some big angle. Did I mess this one up? 30. How did I mess this one up? Okay, I figured out my error. Sorry, I need to take the square root, right? I missed the fact it was n squared here. So I need to take the square root of 30.25. I don't have a calculator on me, so I'll show you guys a trick. I'm going to convert this to a fraction. So 30 and 0.25 is going to be some number of fourths, right? 30, how many fourths are there for in 30? Well, it's 120, right? So 120, and then plus one more fourth. So 121 fourths. And then I take the square root of this, and it's much easier to do. The square root of 121 is 11. You just figure that out?
Wow.
The square root of 4 is 2, so it's 11 over 2. So I messed up on that one. I'll put 11 over 2. So that's n is 11 over 2, or, 5.5. All right. So we can substitute this value in, to find the measure of angle WVZ. So in this case, it's 5.5 times 9 plus 4. I'm just going to do it here. Times 9 plus 4. 9 times 5.5 is something. 500. 55 minus, whoops, 49.5. 49.5 plus 4 is 53.5. Cool. And since we know that Vx bisects angle YVW, then we just need to double it, right? So we just multiply it by 2. Yeah. So we multiply it by 2, and we get 107. Cool. So we're going to go ahead and pause right here, see if we can do these ones. Okay, so you should have gotten 73 for that one and 36.5. All right, and then a final reminder here, squares, as it turns out, have 4 sides that are congruent. All the angles are 90 degrees. Therefore, they have all of the properties of both a rectangle and a rhombus. So here's our Venn diagram real quick. You guys know how these work. This space represents all quadrilaterals, right? So I have like some kind of 4-sided shape in here. The parallelograms are in this circle. So all parallelograms are in here. Some of the parallelograms are rectangles, so they're in here. Some of the parallelograms are rhombuses, they're in here. Anything that is both a rhombus and a rectangle is a square. So that's why squares fall in here. So keep this in mind that we'll use this in our future problems, actually. Okay, I'm going to do 9.4 real quick, too. So 9.4 is just the conditions of rectangles, rhombuses, and squares. And we have a few The conditions for a rectangle, we covered this one. They're a parallelogram with a 90-degree angle. At least one. Once you have one, then you know that they all are, because you know that this one and this one are supplementary, so that must be 90. You know the opposite ones are congruent, so that one must be 90, and this one must be 90. So we only need to prove that one of the angles is 90 if we know that it's a parallelogram. Similarly, if we can prove it's a parallelogram, then we could say that the diagonals are congruent. So BD is congruent to AC. We can say that this is a rectangle. Okay, rhombuses. Again, rhombuses fall within the parallelogram space. So if we can prove it's a parallelogram, then we need just a little bit of additional information. And as it turns out, if we can prove that consecutive sides are congruent, so in this case, EF is congruent to EH, remember that on parallelograms, opposite sides are congruent, so FG is congruent to EH, and GH is congruent to EF. Therefore, all the sides are congruent. Therefore, it's a rhombus. So all we really need are two consecutive sides to be congruent. Similarly, with the diagonals, it's one of our properties of these guys is that the diagonals are perpendicular. So if we have diagonals and they're perpendicular, we know it's and it's a parallelogram, we know it's a rhombus. And then finally, our third property of rhombuses are that if angles are bisected, right? So if angle EFG here is bisected by the diagonal, and it's a parallelogram, we know that it's a rhombus as well. Okay, so we'll do an example. This one here just asked us to determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So we have our little shape here, and we'll start off, I'm just going to go ahead and mark this on here as we get our information so we can kind of visually see what's going on. It says AB is congruent to CD, so I'm going to mark that. AB is congruent to CD. And then it says BC is congruent to DA. So BC is congruent to DA. Okay, so what shape is this, wife?
Rectangle?
Nope, we don't know it's a 90-degree angle.
Rhombus.
If opposite sides are congruent, then it is
quadrilateral.
So if I have a side of 3 and a side of 3 and then a side of 2 and a side of 2, it must be a... It's a hard word to spell. Especially if
dodecahedron.
Stutter. It's a
parallelogram.
Didn't
I already say
you
that?
said that so many times. Okay, so it's a parallelogram because we know that opposite sides are congruent. Yeah. So then we get the information that AD is perpendicular to DC. So AD is perpendicular to DC. So we can say, oh, look at that. That's a 90-degree angle. So now what type of shape do we know this is?
Thought we agreed you weren't asking me questions.
No. This is fine. So this one, I'm just going to draw a parallelogram.
Rectangle.
Oh, so now we know it's a rectangle. Yeah. Rectangle all the way this way. Rectangle. And then finally, our last bit of information is that AC is perpendicular to BD. So AC is perpendicular to BD. So it's not only a rectangle, but it's also a rhombus, correct.
This is what I said.
Yeah. So what shape is both a parallelogram, a rectangle, and a rhombus? It's a square. You're right.
Said
So it is a square. You said it was a square, which is correct. Okay. So so this information tells us it's a parallelogram. This in conjunction with the fact that it's a parallelogram tells us it's a rectangle. This in conjunction with the fact that it's a parallelogram tells us it's a rhombus. And then the fact that it's a rectangle and a rhombus tells us it's a square. Cool. And they write it all down here. Okay. Go ahead and pause right here. See if you can do this one. Ah, look at that. It was a trick question. You can't prove anything with it because we don't even know if it's a parallelogram yet. Remember, that was kind of our first step, was to prove that it's a parallelogram. Okay, that's it. That's all I got. Thanks.